Okay, hi everybody. So I'm here to right a wrong here. So one of the things is it was just pointed out to me. Thank you to the person that pointed this out to me. I will. I want to. I want to redo part of this problem. Okay, I got off. So here's my error. I got off on the wrong track. Everything was described correctly when I was trying to show you the convention that I use to add some of the OHs to the cyclic version, the cyclic hemiacetal version of the monosaccharide once we've made it into a cyclic form. But what I had done here, and the reason I'll erase it here in a minute and I'll redo it for you. I think it was right around, I started this right around minute 42 of the video, just FYI, just to kind of show you where you're at. You can identify it. And you'll see it once I show you with my, well, let me just show you with the laser pointer. Back to the laser pointer. Okay, I talked about just reproducing this molecule up here, down here, but you'll notice everything was going okay until carbon number 4. Notice that I put the OH group to the right instead of to the left. So this OH group was supposed to be here and this hydrogen was supposed to be there. I apologize for that mistake. So what I want to do is I want to redraw it correctly, and then of course that means if you think about, again, I'll describe what I've done, that if you haven't been through this already, but I guess you will have if you're watching the correction probably, but the OH group at carbon number 4 here should be pointed up because it was left over here. So let me do this. Let me erase, oops. Let me erase, sorry. Oops, I'm not able to. There we go. So let me just do this. I'll clean this up a little bit. Well, let me just erase the whole thing and talk you through it one more time. I think that'll be best. Okay. I think what we'll do here is we will then erase that, erase this, same thing here and here and here and here. So that's probably where we were. I'm sure that's where we were in the other video when we, at this point. So, all right, so let me go back here, and what I'm going to do is I'm going to reproduce galactose, D-galactose down here. And the whole point of doing this was to show you, extend it a little bit. We'll put our aldehyde here, put our CH2OH here, because up until now we had figured out, okay, let me just recap where we were. We had talked about, okay, how do we figure out how to put the OH, whether to put the OH group up or down on the anomeric carbon. Same thing with the CH2OH, carbon number 6, and the OH attached to that. But what we hadn't done is said, okay, this OH and this OH and this OH, where do they go on the ring? Now, the convention is this. You can, if you want, memorize the fact that if you're looking at the monosaccharide as drawn, the OH groups on the right end up down. The ones that are left over on 2, 3, and 4 in this case, the ones that are on the right are down. The ones that are on the left are up. If you like, go ahead and just do it that way if you'd like. And I think I mentioned that in the original video. But what I generally do, I'm a visual person, so let me actually make sure I get it right this time. So OH, the second 2 here, or I should say this is carbon 2, right? 1, 2, 3, 4, 5, and 6. And then there's an OH there on carbon number 5. So, and then I'll just write my hydrogens as well. Again, we call carbon number 5 the penultimate carbon. We would have discussed that already. So, all right. So where are we at? I guess I can get a highlighter if we want. And I think we had done, so now we're looking at carbons 2, carbons 3, and carbon 4, because those are the ones I've highlighted up here, right? And we're trying to say, okay, where do the OHs go and where do the H's go? Meaning up or down for both. And I told you, again, back to that original video, I just had one of the OHs in the wrong spot. What I like to do is I like to think about just, if I'm thinking about just that monosaccharide, I like to think about, why can't I get back to my pen? Are we good? Yeah, I like to think about just tipping it to the right. So tip to the right. Okay, if I tip it to the right, then, and again, you can, you know, some of you are really visual people. Let me put an H there. You could actually just do this maybe in your head, okay, and if not, that's okay. But, you know, basically, if we tip it to the right, I'm just going to put everything else where it goes, hopefully correctly this time. OH, 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 OH. Okay, have I done that? Yeah, and then H, and then H, H, H. Okay, and then again, this is D-galactose. So the reason I do that, and let me just, you know, summarize it, and then I'll color code it as well, like I did in the other video, is I think about tipping it to the right. And then the cool thing about that is, let me renumber everything, 2, 3, 4, 5, 6. So it's really carbons 2, 3, and 4, again, that we're interested in. The OH groups are where they should be, meaning the OH group at position number 2 is pointed down, so I come up here and I put an OH group down, okay? The OH group at position number 3 is up, so I put it in the cyclic hemiacetal form. In the cyclic form, I put it up, okay? Same thing with carbon number 4. 5 and 6 and 1 are already accounted for, right? The only other one that's outstanding is 4. The OH group is pointed up, okay? And again, the hydrogens go in the other places, right? The hydrogen at 2 is up, the hydrogen at 3 is down, and the hydrogen at 4 is down as well. Okay, and again, we were, you know, I think I color coded that last time with, maybe it was I feel like it was a different color. Yeah, different color highlighter. I think I had green if I remember right. So it was like OH down, right, and then down, and then OH up, and on 3, and it's up on 3, and OH up on 4, and it's up on 4. Okay. Yeah. So again, I apologize. I just had when I reproduced the D-galactose, I had just put that OH group at position number 4 in the wrong spot, and that's what obviously caused confusion. So thank you for bringing that up again. Hopefully, this is helpful in clarifying that. Okay. Also, you know what? It looks like there's a hydrogen here missing, so let's just add that for good measure. Let me just scan it and make sure. Okay, yeah, looks good. Okay. All right. Call it good.